Hello, we are back to today's practical. Now, in today's practical, we are going to look at qualitative analysis. Test on unknown inorganic compound. Test on unknown inorganic compound. I will answer that qualitative inorganic analysis is a technique being used for the detection of the electron in the form of cation, that is the basic radicals, and anion, acidic radicals, present in inorganic compound, especially salt. And the ones we are going to look into today is a compound. Even though we say it's unknown, but to us it's known now. We know everything about it. It is for us to detect now. To us, the known we are going to look at is iron 2 tetraoxosulphate. Iron 2 tetraoxosulphate. That is a compound we are going to look. So we are going to look at the two radicals, basic radicals and the acidic radicals. That is what we are going to test. That is iron and sulphate. Iron is the basic radicals. That is called cation. And the sulphate is the acidic radical called anion. So that is what we're going to. Now you're going to follow the instruction. First of all, the specimen D, which you have there, is a compound of iron 2 tetraoxosulphate. Then you mix it with water, test it with litmus paper. When you mix it with water, in observation, you write what you see there. Then you test it with litmus paper, you write what happened there. Then at inference, you now tell us if that compound is totally dissolved or partially dissolved. Is it clear? That's what we're going to do. So therefore, whether the compound is soluble or insoluble, also totally dissolved, partially soluble or insoluble, anyone you see with your two eyes, you write it there. Oh yeah, start the work now. Mix it with water and you stir it well and know whether it is totally dissolved or whether it's partially dissolved or completely dissolved, soluble or insoluble. How is it? Check it. Turn it now, stir it well, and see what happens. Is there any particle still remaining inside? Is there any particle still remaining inside? Check, observe what you are doing. Turn it now. If it is soluble or not soluble, we want to know. At the observation, what we saw here is that D dissolved in water to give light green solution. To give light green solution. Then test it with that blue litmus paper and see what will happen to it. Place the blue litmus paper right under that one too. It turns blue litmus paper red. That is what you are seeing there. That place just under. Also you plus litmus paper. Up here. Plus there you now write it turns blue litmus paper red. It turns blue litmus paper red. Then at the inference, what are you going to say? You are going to write solution D is acidic at inference. Solution D is acidic. You are going to divide that solution D now into two. You are going to divide that your solution D now into two. Using that test tube now. Using that test tube. Everybody has a test tube now. Then we are going to test it with sodium hydroxide in drop and then in SX. Don't put that in there. Banye a test tube. Like a banye. Pour it into the test tube. Drop it into that place and drop, and observe what is happening. Observe what is happening. Drop and drop and drop and drop. And drop and drop and drop. What is happening? It's turning to what? You have green gelatinous precipitate. Green gelatinous precipitate form. Let me see. Green gelatinous precipitate form. That is nice. Green gelatinous precipitate form. In excess. Drop that in anemia in excess. Did it dissolve? No. It did not dissolve, Abi? No. So the precipitate is insoluble. The precipitate is what? Insoluble. Then keep it for some times. Let's see what happens to it. Find somewhere and drop it for some times, or you can hold it for some time. Hey, move from the water. Just find somewhere and drop it for some times, and let's see what happens to it later. When you drop sodium hydroxide into the solution, green gelatinous precipitate formed. Influence here, ion 2 present. When you put it in excess, the precipitate is insoluble. Ion 2 present. In essence, the precipitate is insoluble. Then ion 2 present. Now let's see what happened to that and bring it out. Let's see what happened to it. Whether is there any change. And when form, it turns to brown. I think so. Yes, it turns to brown. Let me see your own. Your own did not form well. Bring it. Yes, you see it. It turns to brown. That one is the correct one. Bring it. Let me see. Bring it. As standing, it turns to brown. As standing. Forming ion 2. Ion 2 oxide. Ion 2 oxide. Oxidized. Now, that ion 2 oxide, that ion 2 present, then as you drop it on the air, it has a reaction with the air. Then, the ion 2 now oxidizes to ion 3. He receives oxygen and now forms to ion 3. You have the other beaker now, the other test tube. So now look for acidic radical. Now, the instruction is that solution D plus barium chloride plus hydrochloric acid. Let's see how it will be. Now, I will put the chain. Yes, that one. That's solution D. That original one. Pour it inside of that test tube. Just pour it. Yes. Pour it inside the test tube. Just small. Then add barium chloride. Look at barium chloride here. Come and take it too. Come and take barium chloride. That one is what? Is it water? Okay, pour the water. Use it and come and take this barium chloride. Take the barium chloride. Open it. Shake it so that you. Wait. The main one, they turn it back. Okay, go to your seat. Now, add barium chloride to the solution. Then let's see what will happen at observation. Just add it. Add barium chloride here. Okay, barium chloride, you have a white precipitate form. Abi? Very nice. And that shows that the cations that can give us white precipitate are calcium trioxo, sulfur trioxo, sulfur alone, or tetrasulphate. We have trisulphate, tricarbonate, and tetra. So all these things they have similar character, but we are going to find out exactly which one is present there. So you are going to add hydrochloric acid to know exactly which one is present in that place. Now, so that white precipitate are formed in that test tube. Put in that hydrochloric acid. Come, let's see what happens. Which one is that one? Pour the thing inside it now. Anyhow you want to do it. Then pour it inside. Anyhow you want. In drop, and then in excess. Let's see what happened to it. In drop and then in excess. Let's see what happened to it. Did it dissolve? Yes. Did it dissolve? The white precipitate will dissolve, or the camille. So it did not dissolve. Look at it there, it's with your eyes now. The white is still white in color now. So that your test tube has different color. See this one. This one is white in color. And see that one too. So the white precipitate did not dissolve. Therefore, this radical, acidic radical, tetraoxosulphate, is present. What you are going to write here is that the white precipitate did not dissolve. Here in the inference, tetrasulphate present. Do that in your book. Yeah, the white precipitate did not dissolve. The white precipitate did not dissolve. Therefore, tetrasulphate, SO4, raised to power 2 minus radical, present.